Hello, today we will be going over the 2013 AP Calculus BC free response question number 5. So let's get started. The question states that consider the differential equation dy over dx equals to y squared times 2x plus 2. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals negative 1. Part A. Find the limit as x approaches to 0 for f of x plus 1 over sine x. Show all the work that leads to your answer. Part B. Use the Euler's method starting at x equals 0 with two steps of equal size to approximate f of 1/2. Part C. Find y equals f of x, the particular solution to the differential equation with the initial condition of f of 0 equals negative 1. In order to solve the question in part A, we know that the initial condition limit of x approaches to 0 of f of x plus 1 over sine of x is given. We have to show our work that leads to our answer. So if we try to simplify it, we can't really cut the numerator, the denominator, separate it, simplify it, and collapse it. So we have to refer to plugging in limit of x approaches to 0 for the numerator and denominator separately. If we do that, we can find out that the numerator leads for the limit of x approaches to 0 of f of x plus 1 is equal to f of 0 plus 1. And since we know f of 0 is negative 1, we can just plug that in. Negative 1 plus 1 would give us 0. Now for the denominator, the limit of x approaches to 0 of sine of x would just be sine of 0, which is 0. Now if we know this, it will leave us to a 0 over 0. And we've seen this before. This is the L'Hopital's case rule. The L'Hopital's rule works for infinity over infinity and negative infinity over negative infinity, and a combination of all these. So in this case, we're finding 0 over 0. And L'Hopital's rule states that the limit of x approaches to c for f of x is equal to 0, and if we know that the limit of x approaches to c for g of x is also 0, and we also know that the limit of x approaches to c for f prime of x over g prime of x is a constant, or in this case L, then we can conclude that the limit of x approaches to c for f of x over g of x is also a constant, or in this case L. I'm just using these f of x and g of x in this L'Hopital's case to show just what L'Hopital's case is, not necessarily part of the question. So, based on those principles, we can say that the limit of x approaches to 0 for f of x plus 1 over sine of x can be used by using L'Hopital's rule. So, that leaves us to the limit of x approaches to 0 for f prime of x over cosine of x. Now, we need to note that f of 0 is negative 1. Right, so the x would be 0, and y would be negative 1. And since we have the differential equation dy over dx equals y squared times 2x plus 2, we can plug in our x and y respectively to solve for f prime of 0. That would leave us to negative 1 squared times 2 times 0 plus 2 over 1, which is essentially 2, right here. There's 2 points here. One for L'Hopital's rule, and one for solving the answer. So, in order to solve for part B, we have to use Euler's method starting at x equals to 0 with two steps of equal size to approximate f prime of 1/2. We know that Euler's method is an approximation, which is given by the new position is equal to the initial position added to the slope multiplied by the step size. Well, we can also conclude that if we're using Euler's method, the more step sizes are given in an interval means the closer the approximation will be. So, if we wanted to solve this, in order to get the step size, we have to take the final, which is 1/2, minus the initial, which is 0, all over the number of steps. So, that leaves us to 1/4. An approximation of f of 1/4 is equal to roughly f of 0 plus f prime of 0 times 1/4. We know that f of 0 is negative 1, and dy over dx is y squared, all multiplied in parentheses 2x plus 2. We can get that and simplify it to get f of 1/4 is approximately -1/2. Now, we can repeat that process again one more time. To get f of 1/2, we know that it is approximately equal to f of 1/4 plus f prime of 1/4 times 1/4. Well, we need to note that f of 1/4 is equal to -1/2. dy over dx is also equal to y squared times, all in parentheses, 2x plus 2. Well, we can take our x and y's respectively and solve for the answer again to get -11/32. Now, there's 2 points at play. There's 1 point for using the Euler's method and the second point for getting the answer correct. So, in part C, we're finding y equals f of x, which is the particular solution to the differential equation with the initial condition f of 0 is equal to -1. So, we know that our initial condition for dy over dx is equal to y squared times, all in parentheses, 2x plus 2. Now, if we isolate the variables and get y's with all the dy's and x's with all the dx's, we can simplify to get this. dy over y squared equals 2x plus 2, all in parentheses, times dx. Now, if we integrate both sides of the equation, we can solve for that and get -1 over y equals x squared plus 2x plus c. Don't forget your plus c because this is not a bound integral. We're leaving this in general form, so we will always have a plus c in this case. Well, we know that f of 0 is equal to -1, which leads us to know that y is equal to -1 and x is equal to 0. If we took those values and we plug them in, we get -1 over -1 equals 0 squared plus 2 times 0 plus c. We can deduce that c will then therefore be 1. Now, if we know c is 1, we can plug that back into our equation, and from there, what were we trying to solve? We're trying to solve for y equals f of x. So if we reciprocate both the sides, multiply by negative, that leaves us to y equals -1 over x squared plus 2x plus 1. These are some basic algebra calculations that you can do in your head, or if the question permits you, you can use a calculator, but I definitely recommend practicing these types and getting easily with all these questions. Now, there's multiple points at play. This one is the big one. There are 5 points that you can possibly get. 1 for separating the variables in the start. That itself, 1 point, easy. Now, we can take the antiderivatives, get the constants of integration, use the initial condition, and solve for y. Those 5 points are what you can earn up to. But note that you can only get 2 out of 5 maximum points if there is no constant of integration. Since this is not a bound integral, we can always assume that there will be a plus c. Now, we also need to note that you can only get 0 out of 5 right if there is no separation of the variables. You need to separate the variables in order to solve this answer. You cannot do it any other way. Here are some tips, tricks, and some help. So my advice on such a problem with multiple steps with very different parts is know what L'Hopital's rule is, know what Euler's method is, and know what the basic meaning of what you're trying to solve for is. If you don't know what you're trying to solve for, you'll never get the question right. You need to analyze and see from what you have and solve the answer. Speaking of analyzing with what you have, with the initial conditions given in the question, use them to your advantage to help you solve the problem. Here are some good FRQs that can help you for solving questions related to these. AP Calc BC 2013 Scoring Guidelines question number 5 has sample questions where you can see how the people were graded on the College Board. Check out the link over here. Khan Academy and Paul's online math notes also contain very good information to help you.